Before going any further, let's be upfront about something, because it actually makes this topic more interesting, not less. The viral framing of scientists fed this question into Grok, and the answer shocked everyone. Doesn't trace back to any named research team, any university, or any published study. It's a video title, not a citation. What is real and genuinely worth digging into is the underlying mystery itself. How did ancient Egyptians, working roughly 4,500 years ago with what most people assume was a fairly primitive Bronze Age toolkit, manage to cut, shape, and polish granite, one of the hardest natural stones on Earth, with a level of precision that still leaves modern engineers impressed today? That mystery is real. It's been debated by actual archaeologists, geologists, and engineers for well over a century. And asking an AI model to summarize the current state of that debate isn't a bad idea at all. It's just not the dramatic AI cracked an ancient secret story the title implies. So let's walk through what's actually known, what's still genuinely debated, and why this question keeps resurfacing every few years as if it's never been asked before. Granite is significant here specifically because of how hard it is on the moss hardness scale. Granite typically lands around 6 to 7, made up largely of quartz. Feldspar and mica crystals fuse together under intense heat and pressure deep underground over millions of years. Copper, which was the dominant metal available to ancient Egyptian craftsmen for most of the Old Kingdom period when the Great Pyramids and major granite monuments were built, sits at around 3 on that same scale. That gap matters enormously because it means a simple copper chisel on its own, struggling directly against solid granite, would dull and deform almost immediately without making meaningful progress. This is the heart of the so-called mystery. Ancient Egyptians didn't have iron tools widely available yet, didn't have anything resembling modern diamond-tipped saws, and yet left behind granite obelisks, sarcophagi, statues, and architectural elements cut and finished with a level of precision that some modern stoneworkers have struggled to replicate even using contemporary power tools. So how did they actually do it? This is where decades of genuine archaeological and experimental research come in, and the answer turns out to be a combination of clever material science, enormous organized labor, and tools that were a lot more sophisticated than the word primitive usually implies. The first major piece of the puzzle is something most people have never heard of: dolerite pounders. Dolerite is a much harder igneous rock than granite, and Egyptian quarry workers used dolerite balls, essentially fist-sized to large round stones, as hammering and pounding tools to literally pulverize and wear away the granite surface bit by bit. Archaeologists have recovered thousands of these dolerite pounders at ancient quarry sites, particularly around Aswan in southern Egypt, which was the primary source of high-quality granite for monuments throughout pharaonic history. Workers would essentially batter the granite surface repeatedly with these harder stones, gradually grinding it down, shaping channels, and roughing out the basic form of an obelisk or block long before any fine finishing work began. This wasn't a fast process, experimental archaeology, where modern researchers attempt to replicate. Ancient techniques using only the tools and materials that would have been available at the time has shown that this pounding method, while slow and labor-intensive, is genuinely effective at shaping granite over time, especially when performed by large coordinated teams of workers rather than a single craftsman. The second major piece involves copper tools used in combination with an abrasive. This is a key detail that often gets lost in the more sensationalized retellings of this story. Egyptian craftsmen weren't relying purely on the hardness of the copper tool itself to cut granite. They were using copper saws and drills as a kind of mechanical carrier for an abrasive substance, most likely quartz sand, which is itself hard enough to cut into granite when applied with enough friction and pressure over time. The copper tool didn't need to be harder than the granite, it just needed to hold and direct the abrasive sand consistently while a worker, or more likely a team of workers using leverage and weighted devices, applied steady pressure and repetitive motion. This is essentially the same underlying principle behind a modern wire saw using an abrasive slurry, just executed with far more manual labor and far more time. Experimental reconstructions of this method including some conducted by researchers specifically trying to test whether ancient tool marks found on actual Egyptian granite artifacts match what this sand abrasion method would produce, have found a strong correlation between the experimental tool marks and the real archaeological evidence. This brings us to one of the most famous and frequently cited pieces of physical evidence in this entire debate, the unfinished obelisk at Aswan. This is an enormous granite obelisk, abandoned partway through its carving directly in the quarry bedrock after a crack developed in the stone, making it unusable for its intended purpose. Because it was abandoned mid-process rather than completed and removed, it offers archaeologists something extraordinarily rare, a direct, frozen snapshot of ancient quarrying techniques in progress, including the channels cut around its edges, the pounding marks still visible on the stone surface, and clear evidence of the methodical, channel-by-channel approach workers used to gradually separate a massive block of granite from the surrounding bedrock. Studying this single unfinished monument has done more to inform modern understanding of ancient Egyptian quarrying than almost any other piece of evidence available, precisely because it shows the process caught in the middle, rather than only the finished result. There's also the question of how these workers achieved the genuinely impressive precision and polish seen on completed granite artifacts, like the sarcophagus inside the Great Pyramid or various granite statues and architectural elements found throughout Egypt. The polishing stage likely involved progressively finer abrasives, potentially, including different grades of sand or other available abrasive minerals, applied by hand over extended periods using leather, wood, or stone polishing tools. This is painstaking, repetitive work, but it's not mysterious in the sense of requiring technology beyond what was available. It requires patience, organized labor, and accumulated craft knowledge passed down through generations of specialized stoneworkers, which is exactly what Egyptian society had in abundance during the periods when these monuments were constructed. It's worth addressing directly why this topic keeps generating so much fascination, speculation, and occasionally outright fringe theorizing, because that's a meaningful part of why an AI-generated answer about it tends to go viral in the first place. There's a persistent strain of alternative history content found across books, documentaries, and online videos for decades now that argues ancient Egyptians couldn't possibly have achieved this level of precision with the tools and techniques mainstream archaeology describes, and that some kind of lost advanced technology, or in more extreme versions of the theory, outside intervention entirely must be responsible instead. This genre has been around long before AI chatbots existed, built around genuinely impressive and visually striking artifacts that do look, at first glance, almost too precise for what most people assume Bronze Age tools were capable of producing. What makes an AI's version of that answer feel shocking to some viewers probably has less to do with the content itself and more to do with the framing and packaging around it. A confident, fluently written paragraph appearing instantly in a chat window carries a very different emotional weight than the same information appearing in a dense academic paper or a slow-paced documentary. Even when the underlying facts are identical, there's also a broader cultural appetite right now for content that treats AI as if it might possess some kind of special insight unavailable to human experts, when in reality, for a well-documented historical and archaeological topic like this one, the AI is mostly synthesizing and clearly articulating research that already exists, rather than generating new knowledge no human had previously uncovered. None of this is meant to take away from how genuinely remarkable ancient Egyptian granite work actually is, if anything. Understanding the real techniques involved makes the achievement more impressive, not less, because it reframes the story from unexplained mystery into extraordinary feat of human patience, skill, and organization achieved without any of the tools we'd consider necessary today, standing in front of a granite sarcophagus polished to a near-mirror finish, or an obelisk weighing hundreds of tons cut cleanly from solid bedrock, knowing that it was accomplished through dolerite pounders, copper tools loaded with quartz sand, and the coordinated effort of skilled workers sustained over years, is, if anything, a more compelling story than imagining some unexplained lost technology did the work instead. It's a testament to what humans are capable of achieving with patience, ingenuity, and enough collective will, rather than evidence that something else must have been responsible. So if you came across a video with this title expecting some kind of stunning new AI uncovered secret, The honest answer is that the real secret has been sitting in plain sight in the archaeological record for a long time, available to anyone willing to read the research, visit the unfinished obelisk itself, or examine the tool marks still visible on granite artifacts in museums around the world. What an AI model can offer is a fast, clear, well-organized summary of that existing knowledge, which is genuinely useful, but isn't the same thing as the AI itself solving a mystery that legitimate scholars had failed to crack. The mystery, properly understood, was never really unsolved in the first place. It just required patience to read through what archaeologists have already carefully documented, the same patience the ancient Egyptians themselves brought to the granite they were shaping, one careful strike of a dolerite pounder at a time. It's worth spending a little more time on the experimental archaeology side of this, because that's really where the strongest evidence lies, and it does. And get nearly as much attention as the more dramatic alternative theories do. Researchers including Dennis Stocks, a British experimental archaeologist who spent decades specifically testing ancient Egyptian tool techniques using only period-appropriate materials, have built working replicas of copper saws and tube drills, loaded them with quartz sand, and successfully cut into granite samples using nothing more than human muscle power and the same basic mechanical principles available 4,500 years ago. These experiments weren't quick. Cutting through granite this way is slow, requiring sustained, repetitive effort over many hours to make meaningful progress on even a modest cut, but slow and labor-intensive isn't the same thing as impossible, and that distinction matters enormously when Evel claims that ancient Egyptians couldn't have achieved this without some kind of unexplained advanced technology. The experiments consistently produced tool marks strikingly similar to those found on actual ancient artifacts, which is about as strong a form of evidence as experimental archaeology can offer for a technique that, by definition, can't be observed being performed by the original workers themselves. There's also a geological piece of this worth mentioning, because it helps explain why Aswan specifically became the dominant source for Egyptian granite work throughout most of pharaonic history. The granite found there has particular mineral characteristics, including naturally occurring fracture lines and consistent grain structure, that made it somewhat more workable using the pounding and sand abrasion techniques described earlier than other granite deposits might have been. Egyptian quarry workers appear to have understood and exploited these natural properties directly, identifying and following existing fracture planes in the bedrock to help separate large blocks more efficiently, rather than relying purely on brute force cutting through solid, uninterrupted stone. That kind of practical geological knowledge, accumulated and passed down across generations of quarry workers, represents exactly the kind of sophisticated, hard-won expertise that's easy to overlook when a civilization's technology gets flattened down to simplistic, one-word descriptions like primitive or Bronze Age, without acknowledging the genuine specialized craft knowledge underlying it. Ultimately, the real story here is less about artificial intelligence and more about how easy it remains, even now, for genuinely well-documented historical and scientific knowledge to feel obscure or hidden simply because most people never encounter it directly. The techniques outlined here aren't secret. They're taught in archaeology courses, documented in peer-reviewed journals, and demonstrated repeatedly through hands-on experimental research. Spanning decades. What changes? When a chatbot summarizes that same information in a conversational, confident tone, is how accessible and immediate it suddenly feels to someone who would otherwise never have gone looking for it. That accessibility is a genuine benefit of these tools, even when the dramatic packaging built around them oversells what's actually happening underneath.